Very good morning, everyone. Myself, V. Mounika. I'm working as the assistant professor in Marri Reddy Engineering College, and today I'm going to discuss about decision tree learning and artificial neural networks. So these are the topics which we're gonna cover in this session. The first one will be decision tree learning, classification of decision trees, and why we use decision trees, and what are the issues in decision trees, and what is artificial neural network, and the key components and working of an ANN and applications of artificial neural network. Next, the first one will be decision trees. So let's look at the definition. So decision tree is a supervised learning technique that can be used for both the classification and the regression problems, but mostly it will be preferred for solving classification problem. So decision tree is mostly used for both the problems like classification and the regression, mainly preferred for the classification issues, and it is a tree kind of structure and where internal nodes represent the attribute set as, and the branches will represent the attribute values, and the leaves will represent the final decision or the predictions. So here in decision tree, we do have two main things. The first one will be the decision node and the second one will be the leaf node. Okay. So the decision node. So the decision node used to make any kind of decision or any kind of multiple, like it may have multiple branches, and the leaf node. So leaf node will be the output for the problem and those decisions, and it will not contain any further branches or any kind of nodes. So the decisions or the test can be performed on the basis of features of the given data set, and it is called as a decision tree because it is very similar to a tree structure, and it will start with the root node and it will expand on further branches and it will construct like a tree like structure. And in order to build a tree, we use the CART algorithm, which stands for classification and regression tree algorithm. And a decision tree simply ask a question like yes or no, so it will give you a simplified answer, and every time it will split the tree into subtrees. So let's look at the decision tree structure. So here we have the first one will be the whatever the first one we are taking, that will be called as a root node here. So in that, the tree has been divided into two nodes, the decision node 1 and the decision node 2. So here it will consisting of two leaf nodes again. So every time the tree structure will start with the root node here, and it will divide it into different nodes. Here the node 1 will consisting of two leaf nodes, and the leaf node will never have any kind of nodes in further. Coming to decision node 2, so here it again divided into one leaf node and one decision node 3. Okay, and the decision node 3 is again divided into leaf node 1 and leaf node 2. So here the decision may be captured in multiple ways. So when the decision comes here, so the output will produce either leaf node 1 or leaf node 2. Okay, and next coming to decision node 2. So here that based on certain condition, the leaf node 1 will get executed, or it might move to the second decision node, and in that, based on that particular prediction, it will give the output. So this is how the decision tree structure will get displayed here. And the classification. So basically the classification has been divided into two different categories. The first one will be the classification trees and the regression trees. Okay, so first look into the classification trees. So here they are designed to predict the categorized outcome, and they classify the data into different classes, and they can determine whether an email is spam or not spam based on various features of the email. So classification, as we know, based on certain condition, the root node has been divided into two different categories. Again, if it might have divided into again further branches. Okay, this is how the classification trees can be classification can be done. Coming to regression trees, so these are used when the target variable is continuous and it predicts a numerical values rather than the categories. So coming to classification trees, as we have seen, based on certain condition or based on certain decision, the tree has been categorized into next level of nodes. So coming to regression, here we will categorize the things we'll never categorize the things here. So based on certain variable values, so we'll use the regression trees. So whatever the target variable is there, that will be changing continuously, and it will predict the numerical values rather than the categories. For example, a regression tree can estimate the price of a house based on its size, location, and other features. So let's consider this example, estimation price of a house. So in the middle of the city, we might have a maximum price for the house based on certain based on the size or the location or any other features, or G plus to G plus, so that we can verify the price of a house. Or let's take a village. So the same square feet of the house will may vary the price. So this is how the prediction can be determined based on certain features here. So this is how the regression trees can be used in decision trees. Next. So there are various algorithms which will be used in machine learning, and the best one will be used for the given data set, and the problem is the main point to remember while creating a machine learning model. So what is the main use of taking decision tree? So we'll see. So the first one will be the decision trees are mainly having a mimic human thinking ability while making a decision, so that it will be easy to understand. When we make any kind of, let's say we are taking any kind of family tree, so we can easily understand we do have a grandparents in the top, then our parents, and then we are the kids. So this is how the classification can be done on the basis of our family structure. So it will be easily understandable while looking at the picture, and the logic behind the decision tree can be easily understood because it shows a tree like structure. So based on certain condition only, the tree has been divided into certain categories, so that the human can be easily understand how a decision tree has been classified. So let's see some terms in the decision trees. So let's start with the root node. So as we know, every tree has start with the very first node will be called as a root node. The root node is from where the decision tree starts, and it represents the entire data set, which further gets divided into our more homogeneous sets. The main root, which is at the starting point, that will be called as a root node here. Next, coming to leaf node. So leaf node are the final output node, and the tree cannot be segregated further after getting a leaf node. So when any kind of node is noted as a leaf node, that will never have any further branches or further nodes. Next is splitting. So splitting is a process of dividing the decision node or the root node into subnodes according to the given condition. So splitting is nothing but based on certain condition, we'll split the tree into certain classifications. Next, branch or subtree. So a tree can be formed by splitting the tree, as we know. And pruning. So pruning is a process of removing the unwanted branches from the tree. So it is a kind of cutting the unwanted nodes from the decision tree. Next to parent node. So the root node of the tree is called as a parent node. So parent node will be considered whenever we have a child nodes from the existed node. Then only that node will be considered as a parent node. Next, child node. So other than the parent node, the remaining nodes will be called as a child nodes. So these are the basic terms will be used in the decision trees. So let's look into the issues in the decision trees. So these are the main disadvantages, let's say. The decision trees can grow to be very complex or require pruning and optimization. So whenever the size is getting increased, we need to do the process of pruning. And next, overfitting is a common issue, again requiring pruning and optimization of hyperparameters again. The approach can be less accurate with the regression problems than the machine learning techniques, especially with the continuous numerical outputs, and prone to bias in machine learning models if the training data set is not balanced or represent. So these are some basic issues for in the decision trees. Let's look at the topic of artificial neural network. As we know, artificial neural networks, as we know, we do have neurons in our body, so that the body will function in a particular way. So as like human, the systems will have a neuron technology, where the neurons will act like a human brain, so that it will work on certain condition. So, a neural network is a method of artificial intelligence that teaches the computers to process the data in a way that is inspired by the human brain. So, let's how a human brain will work on certain situations. So, same like we'll create the artificial neural so that it will work like same like human being, and it is a type of machine learning process called deep learning. Thus, that uses the interconnected nodes or the neurons in a layered structure that resembles the human brain, and it creates an adaptive system that computers use to learn from their mistakes and improve continuously. Thus, artificial neural networks attempt to solve complicated problems like summarizing documents or recognizing faces with a greater accuracy. So, how a human will learn from the mistake, the same like here, the artificial neural will learn from the mistake and it will update themselves. So why neural network is important, let's see. So neural networks can help the computers to make intelligent decisions with the limited human assistant. So this is because they can learn and model the relationship between the input and output data that are non-linear and complex. So with the help of artificial neural network, we can make our own predictions with a minimum human help. Okay, so that's the reason artificial neural networks are came into picture. So let's see the key components of artificial neural networks. So basically we do have three different layers. The first one will be input layer, and the second one will be hidden layer, and third one will be output layer. So the first one will be input layer. So this is where the network receives the information. For example, in an image recognition task, the input could be an image. So as we know, input is nothing but giving some kind of data to the system, so that will be considered as an input. So same like here in the input layer, we do give the information as a data set. Let's look at this example, image recognition task. So to recognize one image, first we need to give certain image so that it will recognize that particular image. Next, hidden layers. So these are the layers that can process the data received from the input layer, and the more hidden layers are there, the more complex patterns the network can learn and understand. Each hidden layer transforms the data into more abstract information. So we do have a structure called this. So here this will be the input layer, and these two are the hidden layers here, and this will be the output layer. So whatever the data we are giving from the input layer will be received here, and the data will get processed to the hidden layers. As we have the data will get shared over the all the hidden layers. Let's say we are sharing the information from the node 1. The node 1 information will get transferred from node 1 in the hidden layer, node 2 in the hidden layer, node 3, node 4, node 5. So the particular information from one node from the input layer will get shared over the all the remaining nodes in the hidden layer. Okay, so this is how the information can be transferred from input layer to hidden layer. Okay. So output layer. So after passing to all the layers, the network will give its final prediction like classification and image as a cat or dog. So here, so this input layer will take the will from the input layer will give the data, and the hidden layer will perform all the task and it will generate some prediction, and that prediction will get transferred to the output layer. So here we do have 4 output layers, so that it will give the prediction from this output layer. So input layer will take the information, the hidden layer will transfer the information, and that information will get displayed over the output layer. So this is how a neural network architecture will be there. Okay, so we'll see the working of artificial neural networks here. So artificial neural network work by learning patterns in a data through a process called training. So during the training, the network adjusts itself to improve its accuracy by comparing its predictions with the actual results. Let's see how the process will work. Um, Coming to the first layer, input layer, data such as image or a text or a number is fed to the network through the input layer. And the hidden layer, each neuron in the hidden layer performs some calculations over the input and passing that result to the next layer. So here the data is transformed and the abstracted at each layer, and the output layer, after passing all the layers, the network will give its a final prediction. Let's say we are feeding some image, like we are giving some cat images, some dog images as a input. So whatever the middle layer we are having, that is hidden layer, will classify the things and it will generate the output to the output layer. So the output layer will classify these are the certain images of cat, and it will classify these are the certain images of dog. So this is how the data can be categorized from the hidden layer to output layer. Next, let's see the applications of artificial neural networks. So, in general, we are using artificial neural network everywhere. Let's look at some applications here. The first one will be computer vision. The computer vision is the ability of computer to extract the information and insights from the images and videos. With a neural network, the computer can distinguish and recognize the images which are similar to the humans. The computer vision has several applications such as following: visual recognition in self-driving cars, so they can recognize the road signs and other road users, and content moderation to automatically remove unsafe or inappropriate content from the image or the video archives. So computer vision, so the computer vision will have some sensors so that it will detect the information, or it will extract the information from the images and the videos. Let's look at the first example, visual recognition in self-driving cars. Let's say we are using any self-driving car. So the car, whenever the car is getting in a developing stage, it will undergo some training procedures so that it will identify the traffic signals whenever we are having what say any human is passing before the car, or any kind of animal is passing, and any road signs, so that any kind of left route, right, so that it will be get trained on all those things, so that the automatic car will drive in a particular manner. Okay, so this is how it will, so that we are feeding the data, like, so these are the kind of signals you should stop, these are the signals so that you can proceed, so these are the signal you can stop. Let's say we are any animal is passing before the car, so that we have to slow down the car. So these are the certain kinds of instructions to be given to the car. And second example, the content moderation. So let's say to nowadays we are using social media, right? So we can, like, we post any kind of photo or video or anything, we can get any number of comments with a positive or in a negative manner. So that we do have a content moderation where it will automatically remove the negative comments from the social media. So this is how the computer will detect each and everything. Okay. And next is speech recognition. So neural network can analyze a human speech despite of varying speech patterns, pitch, tone, language, and accent. So virtual assistant like Amazon Alexa, automatic transcription software use speech recognition to do tasks like these. So first, assistant call center agents and automatically classify the calls and convert clinical conversations into documentation in real time. And next, accurately subtitle videos and meeting recording for wider content reach. So speech recognize. Let's say nowadays we are using Alexa at our home. So the Alexa is built with certain kinds of instructions so that it can listen the voice of any kind of human being. Okay, so it will take the input as a voice, irrespective of the pitch, tone, language, or accent. It will receive the content from the human so that it will react upon the certain condition. So this is how the voice recognition can be done. Okay. So first example, assisting the call center agent. Let's say we are calling any kind of banking regarding any query, so that at the first we'll never get connected with the agent directly. So first we do have a bot communication, so that the many of the calls will get classified based on certain basic rules. Let's say we will get divided based selection of voice. Let's say I'm a Telugu person, I will choose Telugu, so that my call will get connected with the Telugu people. This is how the classification can be done without reaching human directly. So these are certain speech recognizing techniques where most of the work can be done in a easier manner. Okay. And next, subtitle videos. So like we're scrolling any kind of movie or any kind of song, we can see the subtitles in the below of the video, right? So that we can easily, the speech, the voice of the song or the video can automatically transcript it to the subtitles, so that we can easily understand what was going on the. Okay. So this is how the speech recognition can be done. And next, NLP, that is natural language processing. So natural language processing is the ability to process the natural human edited text and next human created text. And neural networks can help the computers to gather insights and meaning from the text data in the document. So NLP is nothing but is the ability to understand the human speakable language, let's say, or a human created text. So it has some several use cases. The first one, automated virtual agent chatbot, as we discussed, and automatic organization and classification of written data. So by seeing or looking at the data, we can easily classify the data, right? So same like human, the system will recognize and classify the data. Next, indexing of key phrases that indicate the sentiment like positive or negative comments on social media. Again, the document summarization and article generation. So these are the basic things can be done with the help of artificial neural network with the help of NLP. And next, fourth one will be recommendation engines. So neural network can track user activity to develop the personalized recommendation, and they can also analyze all the user behavior and discover new products or services that interest a specific user. Okay. So as we know, nowadays we are using social media, like, so giving recommendation. Let's say I'm searching for a particular product in Amazon. Let's say I'm looking for a watch. If I open the Amazon, if I search for the watch, it will display the related watch, right? So whenever I close the application and I again reopen the application, it will definitely show the watch history over the home page. So this is how the individual information will get personalized over there. Okay. So these are the things can be done with the help of artificial neural network. So each and every individual data will get stored in the applications, and whenever we open that particular application, it will give the similar kind of information. Let's look at the first example, Netflix. It will suggest the movies and the TV shows, and it analyze your viewing history, show ratings and the viewing habits of similar users to curate a personalized row of content. So whenever we open any kind of OTT application, let's say we have seen any kind of scary movie once, so it will suggest the scary movies in a line. Okay. Let's say we are moving, have seen any kind of funny movie. Let's say it will display the same content like previously I watched. So this is how the personalized information can be stored in the application, and it will give the same similar kind of information whenever I open the application. And next, Amazon. So recommends the physical products, and it uses like customers who bought this item also bought by analyzing your purchase history and browsing the behavior. Let's say I purchased one dress, so I So it will show, given in the below, it will show a comment like customer who bought this item also bought. So some other customer will has bought the particular dress with another dress, so that it will show, it will display the same message to me, so that I can see the dress. So this is how the personalized content can be displayed over the homepage, so that we can analyze. So this might be a good option for me. Okay, this is how the recommendation can be displayed over the applications. Next is Spotify. So create the custom list, and it analyze the types of songs you skip, and your listening patterns and the audio characteristics of the track to build personalized stations like Discover Weekly. So whatever the songs we are listening regularly, those songs will get give as a suggestion. Okay, and YouTube. So drives your video feed and will track what you click and how long you watch, and what users with the similar profile enjoy your recommended your next video. So this is how the recommendation can be get displayed over the YouTube. Once I watch one kind of video, so every time when I open that kind of videos will get displayed over the homepage, so that I can enjoy my own comment. This is how the recommendation can be given with the help of artificial neural networks. Thank you.